All right, so today we are looking at exponential function manipulation. Heard of it? We're looking at exponential function manipulation. Sahan. What we need to be able to do today is to use the exponent laws to identify different possible equivalent transformations of exponential functions. So the main idea today is we're going to look at rewriting exponential expressions in different forms with an idea of identifying different types of transformations that they could have. So we're using mostly these three of the exponent laws. The product property, you should be familiar with. This one. And we see it here used in this example. X to the 5 times x to the 3 is x to the 5 plus 3, which is x to the 8. The power property, if we have x to the 5 all raised to the 3, that's x to the 5 times 3, which would be x to the 15. And the negative exponent property, x to the minus 1 is 1 over x to the n, or x to the minus 3 is 1 over x to the 3. Those are some examples. So, using these rules, we want to so we're not going to use the rules. We are going to have a look at these 4 examples here. What is the horizontal transformation in each one of these? So, what horizontal transformation have we got in this first one? So, if we're looking at this one in f of x. So if you think the function, the base function is f of x, or let me call it g of it, let me call it y of x, is equal to 4 to the x. Now if we've transformed that into f of x, what transformation has occurred? What transformation has occurred? Is it by plus 2 or minus 2?
It goes there. Plus 2 means it goes into negative.
So, is h plus 2 or minus 2? Minus 2. So the h here is minus 2. So this is a horizontal translation by minus 2. So left 2 units. Okay, here in this next one, what is the horizontal transformation occurring here? Horizontal dilation? What's the factor? Right. What factor? Is it 3 or a third? Are we stretching or compressing? We're compressing. So what would the factor be? 1/3.
If the value is 2, isn't it just stretched by 2 or no?
No, that's the base of the original function. So that's not the transformation. So the original parent function here is 2 to the x. And then some kind of horizontal transformation has been applied, and that's where the 3 is coming from. So if I use some other function, y of x is equal to 2 to the x, then g of x is equal to y of 3x. You see how I'm applying a transformation here in this one?
Yeah.
So the 2 is part of the original base function, or the base of the original function. Okay, what type of transformation do we have here on this one? Horizontal dilation? Horizontal dilation? Factor 2. So will it be a stretch? What's the horizontal transformation happening here? Abdallah, is it you giving a? What's it going to be, Abdallah? Horizontal translation? Translation by +1. So 1 unit, which direction? To the right. Okay, so what we're going to do is we're going to re-examine the examples that we just took. We can see the exponent properties rearrange the function into equivalent form. So using the product property, we could take this function here. Ooh, where's my pen? Sorry. We can take this function here, and we could separate it out like this. And then we could bring that 4 squared to the front here. What type of transformation do we have now? Vertical dilation by factor 16. What transformation was it originally? Horizontal translation left. We've changed it. And it's completely changed from a shift to, we have a shift 2 to the left. Now we've got a stretch by factor 16. Exactly the same graph. Exactly the same graph. Should we have a look at it? I think maybe I can pull up my GeoGebra from the other day and we can see that. Let me just. Let me just type them in. What were the 2 functions? My x plus 2 and 16. X to the 16. There's that one. And we want to see, is that the same as y equals 4 to the x? Was it minus 2 or plus 2? It was plus 2. Ooh, look at that. They're the same functions. They're the same functions. Let me just go in on this one. Let me change that to a slider. So I've made a little slider. Watch as we move this across like this. Can you see? We've got the stretch there in green. And as we move this across, it lies on top of it. Can you see it happening? Okay. Okay, so what we can say is, and this is our important idea, every horizontal translation of an exponential function of the form f of x equals b to the x plus h is equivalent to a vertical dilation of the exponential function f of x equals a times b to the x. And the relationship between a and between the stretch and the horizontal translation is given there. And we can see that happen. So let me just pull that off and do that one for you. So we want to show that bx plus h equals equals bh times bx. Now, you can see clearly from the laws of exponents that this is going to be the case, isn't it? I can't really show that. That's the laws of exponents. Let's have a go at an example of this one. Let's have a look at some examples. So each of the following exponents have a horizontal translation. What is the equivalent representation that has a vertical dilation and no horizontal translation? So there on our first one, we've got, this could be rewritten as 2 to the x times 2 to the 3. And that's 2 to the x times, what's 2 to the 3? That's 8, yeah? So we get 8 times 2 to the x. What is the vertical dilation now? Factor 8. What was the original horizontal translation? Minus 3. Sorry, what was the question? What was the question? No, like he says, the order of operations, you can't do that. So you're looking at here. This. Oh no, you're looking at the next bit, aren't you? Yeah. No. And he's right. It's from the order of precedence of operations. So PUMDAS. So you've got your brackets or parentheses first, and then your don't know what do you say? Up.
Yeah.
I'm getting so confused with my acronyms. So the British one is BIDMAS, brackets, indices, division. The American one, it's PEMDAS. Okay. And I said PUMDAS, which is the Swedish one, which is parentes, uppaid. Sorry, I'm getting a bit confused there. All right, yeah. So anyway, no matter what our language that we're speaking, the second one is definitely some sort of exponents. Exponents come next. So the 2 to the x comes before the multiplication, and we can't switch these ones across. All right. Can you have a go at these two for yourself? What are the vertical transformations? Khalid, your pencil's not working. Okay. Okay, 30 more seconds. All right, let's have a look at our answers. So here on this one, we can write that as 3 to the x. What are we multiplying it by? By 3 to the negative 2? So that's 1 over 3 to the 2 times 3 to the x, which is 1 over 9. So what is the vertical transformation? Vertical dilation by factor 1 over 9. All right, what have we got here? So we've got 4 to the 3 times 3 to the x times 3 squared, which is 4 times 9 times 3 to the x. 4 9s 36 times 3 to the x. What transformation do we have? Vertical dilation by factor 36. Big one. Okay, are we good? Any questions there? Anna? All right, so similarly, we can look at the power property. So what's going on with the power property? If I take this example, 2 to the power of 3x, we can rewrite this as 2 to the 3 all to the x, which would be 8 to the x. So in this case, with the power property, we can remove the transformation by changing the base. So every horizontal dilation of an exponential function is equivalent to just changing the base and removing the transformation. Let's have a go at some examples like this one. So which of the following functions is equivalent to y equals 9 to the 2x? Well, let's take y equals 9 to the 2x and rewrite it using the power property, which is 81 to the x. So any of them match that? D. Have a go at this one for yourself. All right, let's have a look at this one. So we're going to start over here. We've got y equals 9 times 4 to the x. That's 9 times 4 to the x is 4 squared. That gets us our 16, but then we've got to get rid of our 16, like this. So we still have 4. That's going to give us 9 times 16 to the x over 2. Using the idea that 4 equals 4 to the power of 2 times a half, which is 16 to the half. I'm using this idea. So which one matches that? A. No? No? Got too excited? C.
No, 1/60 that'd be like to the negative. So the half is
I like it when other people answer the questions. That's good. No, I'm a bit sarcastic. No. I really like it when you guys answer somebody else's questions. It's good. I prefer it if the rest of you listen to the question. Exam style question. While we do the exam style question, I need a volunteer. Somebody go and collect the photo. I've printed the classwork sheets, 20 of them. Have a go at the exam style question. 2 minutes for this one. Let me pause the video there. All right, so which one do we think it's going to be? Who thinks it's an A? Who thinks it's a B? Who thinks it's a C? Who thinks it's a D? And I will assume that the rest of you don't think. Let's have a look. So g of x is going to be what? It's going to be 3 to the x to the power of b, which is 3 to the bx. This is a horizontal dilation, isn't it? This is a horizontal dilation by a factor of 1 over b. We don't have the factors, but is it A or is it B? Why is it A? Yeah, small print. Look at the small print there. It's telling you B is negative. So we have to have a reflection as well over the x-axis. You could rewrite it, and then that would be vertical, but it's not rewritten. This one. This one is a vertical in this form. This is a horizontal dilation. It could be rewritten, but you wouldn't rewrite it as a vertical dilation. You could rewrite it by changing the base. You can't make this into a vertical dilation. All right, we're finished there for today. Have a go at the classwork activity.